Roger.
Okay, good morning and welcome to the webinar. This is Roger Royce. I'm the founder of the Royce Law Firm. We're a business, corporate, and tax law firm with offices in Northern and Southern California. Today's webinar is on 3D printing or additive manufacturing, which, as you probably know, is a new technology that makes three-dimensional solid objects from digital models. So instead of manufacturing and shipping products, designers can now send digital information to a 3D printer, which will create the tangible product in plastic, polymer, or other materials. So, for example, you can imagine just how big this technology is. So if you see something that you like, instead of going to the store or going online and buying it, maybe you'll just go to your 3D printer and manufacture it. And you can imagine all of the issues that raises, including legal and business issues. Today, we've got two members of the panel who are experts on this technology and how this game-changing technology can change the way that products are made, sold, and taxed. So I want to remind the panelists that if you have questions, you'll notice a dialog box on your screen. You can type your question into the dialog box, and that will be routed to me, and we'll save the questions for the end, and the panelists can each respond to it. In addition, the webinar is going to be recorded and saved at royceuniversity.com as well as on Royce Law YouTube site, and it will be available for download as a podcast in the iTunes App Store. Our panelists today are Jeffrey Doyle. He is a venture capitalist with Percipient Capital and has made some investments in the area. He's actually a mechanical engineer and a veteran British Army engineering officer, so he certainly has some background on this, and he's activated over $50 million of funding of technology businesses. Our other panelist is Roy Worthington. He comes from industry. He's the president of Octave Systems. Now, before I turn it over to the panelists, just to give you a little bit of background, you probably know that the popularity of this technology has been increasing dramatically. And from my standpoint as a lawyer, I see that this raises lots of legal issues. For example, you are probably familiar with the legislation that was recently introduced banning 3D printed guns, since the manufacturer of plastic weapons could circumvent things like background checks, registrations, metal detectors. And secondly, there's been a new type of 3D printer that could use this chemical ink to print chemical compositions. So you can imagine how that may circumvent regulation of chemicals, drugs, etc. And finally, there is just general intellectual property law implications: copyright, patent, registration, trade secret. You can see there are lots of legal issues that are raised, including infringement. And those are the sorts of legal issues that we as lawyers have to be sensitive to as we work through these issues. But first, I want to talk a little bit about some of the some of the practical business aspects of this, how the technology works, and what the outlook is for venture investment. So with that, I'm going to turn it over, first of all, to Jeffrey Doyle.
Good morning.
Morning, Jeffrey.
Morning.
So can maybe you do a presentation on the venture outlook?
Yeah, great. Thank you very much. Thank you for inviting me along to this webinar. My name is Jeffrey Doyle. I'm going to cover 3D printing technologies and investment activity and trends. A little bit about me and ZipBit. I'm the CEO of ZipBit now, having invested in this business recently. ZipBit provides 3D scanning and printing services to Silicon Valley technology companies. We are based in Santa Clara. We also distribute European 3D printers and scanners. And my background in venture capital and the company I set up last year called GrowShapes, I sought to look at the trends both with respect to the technology and the investment in 3D printing related technologies. My CTO is an exceptional find for me. Knowledge is a big problem in this technology, so I partnered with my CTO who founded ZipBit, and we're progressing and growing very rapidly. The agenda, I'm going to go into a bit of background of the technology. I'm presuming there's some people on here that are not quite so familiar with it. I'll then cover off the investment activity over the last couple of years and a few trends with respect to the technology generally. Just to go over the technology, there's a number of types of technologies that you can see there. Extrusion is the one that the majority of people kind of see, both with respect to the commercial side as well as the desktop side, in particular desktop. Most, if not the vast high percentage of desktop printers are using this extrusion technology, where you're basically pushing ABS or PLA or other similar sort of cable through an extruder from about 2 millimeters down to 0.3 of a millimeter, almost like putting ice and sugar on a cake, on layer upon layer. Granular uses powder, so the raw material is powder, which can be metal, ceramic, nylon, plastics, a whole variety of materials, and you either use a kind of a glue or resin to bind the powder, or you use sintering. Sintering is when you kind of melt it, you reduce, you increase the temperature such that it's just at melting point, and you use the layer to melt a particular layer, and then you cover it over with another layer of granular material and repeat the process. So you're kind of building up from a low level all the way up in all these processes along the y-axis, which is the vertical axis. Light polymerized is using a liquid resin, and it uses various lasers to solidify that resin where you want it according to that particular layer, and then again you build up and you build up. Stereolithography is an application of that, as is digital light processing. The final technology is called lamination. I am a distributor for a European laminating type technology company. This has not been formally announced yet, and what it does, it uses a layer of paper, cuts it out, inks it so it's full color, and then it repeats that process time after time until you get your three-dimensional object. So you're turning a pack of A4 paper from Staples into an object. All these processes, all these technologies require post-processing. You cannot just get an end product that is fit for purpose. There's always some sort of process that is required. A few of the players in the market. On the left-hand side, you have the commercial players. This is the more established. You have players like 3D Systems and Stratasys and X1. They're all US companies. They're all listed. Interestingly enough, X1 listed at the beginning of this year with a previous 12-month revenue of just $20 million. Those in the audience who are familiar with listings or IPOs, you know, that's quite a low number, so it shows that there is investor appetite within the markets, the capital markets, to back these companies. EOS is a sintering technology. Machines go up, start at 250 and go beyond. Akram, Swedish, similar. MCOR is a paper laminating technology company from Ireland. The audience might be more familiar with some of the desktop names. 3D Systems has the Cube, which is filament-based. The majority of desktop printers are filament-based, as I have already explained. There are a few at the bottom like B9 Creator and Formlabs, which are more of a stereolithography, liquid resin, photopolymer process. Microboards is there, recently purchased by Stratasys last week. I'll go into more detail about that later in the presentation. Moving on to the next slide. A few facts about this technology. It was invented in the 80s. In 2011, 1,600 articles were published in the US. In 2012, that increased tenfold to 16,000. In aerospace, Boeing has over 10,000 components flying across 10 platforms. In medical, 70,000 guides are printed annually for surgery, 30,000 hip cups for hip replacements have been printed by Nema Corporation. 95% of in-the-ear hearing aids in the US are 3D printed. Dental, Align Technologies, you're probably more familiar with EnvisionTech. They printed 17 million braces last year. And generally, the market is growing at about 30% per annum. And between 1980 and 2011, its compound annual growth rate was at 26.4%. In total, 28 million parts manufactured in 2012. So industrially, across those sectors, it's not a new technology. They've been using it for many, many years. GE purchased Morris Technologies only 18 months ago, I think it was. All fuel pumps on GE jet engines are 3D printed using selective laser sintering. So looking at the consumer market, a lot of the articles that I mentioned focus on the consumer market, in particular the manufacturing of like guns and other interesting things. Here are some pictures of the CES show where there were 11 companies presenting. There were, I think, over 3,500 exhibitors, but only 10 3D printing related companies. But that was a 5-fold increase from the previous year. And within the consumer market, things like phone cases, other gimmicky things are being manufactured by mostly the hobby market, predominantly with the price point as it is at the moment, anywhere between 1,000 to 3,000–4,000. It's targeting the pro-consumer type market and the small businesses with these types of machines. What is interesting from my point of view is the two leading players in the market are building ecosystems across the printers, the software that they used, various web apps, as well as providing services. The clear leaders are 3D systems with the Cubex, though the Cubex is more towards the SMB market, and Microboards, as I said, has recently been purchased by Stratasys. Again, they used to target the lower end, but they are moving up to the more pro-consumer and SMB area of the market. 3D Systems has enhanced their ecosystem predominantly through acquisition, if not wholly, whereas Microboards historically has been growing organically, although recently purchased. Moving on to the next slide, cloud-based consumer services are becoming more and more apparent. I believe that a lot of the mass population will be touching 3D printing through services in the medium term. The printers are quite expensive purchases, as I said, as an electronic piece of kit. Now the education market, however, will and is growing very, very rapidly. Here are a number of players in the service market, including 3D Systems and Microboards, and they are springing up daily. More and more are coming alive. Today I see a lot in Silicon Valley that are trying to replicate a similar sort of business model. Okay, moving on to the investment activity in the recent past. Interestingly, 60% of all 3D relating companies have been formed in the last 5 years. So that shows that there's an increasing appetite for people to engage with this technology and set up companies. The biggest challenge that I see that they face is they do not understand the capability of the technology as a platform. They have some great ideas, but there are a lot of challenges both with respect to the market maturity and how ultimately to make money. People might be familiar with Tinkercad, which was an online cloud-based CAD software, which they shut that down. Autodesk has taken it over, I think because there's a question mark on how to generate revenue from that. Tinkercad has moved to engineering as a market in digital prototyping, I believe, but some people might be able to improve on that thesis of mine. This chart shows that 3D printing related technologies is a very small component of VC investments in 2012. 50% of all VC investment in the US occurs in the state of California, 40% in and around Silicon Valley. The majority of investment up until recently has not been West Coast based, it has actually been East Coast based. But this shows me that the VC community is kind of dabbling around the edges of this technology, not quite sure how they're going to make money, and there's some reasons why they are not committing wholly, which I'm quite happy to elaborate on later. Looking at the actual investments across the US and EU over the last couple of years, it is minute. 29 million in 2011 split hardware, software, marketplace services. These are representative of the breakup. And into 2012 it increased 9%, and a real big shift which does not really represent anything because so few companies have been backed in where the money is going between hardware, software, marketplace and services. Crowdfunding is supporting the desktop RepRap hobbyist market. There was a 4,000% increase in funding via crowdfunding type websites between 2011 and 2012. 2011 was predominantly Printable, which raised $840,000. And in 2012, last year, a big chunk of that has come from Formlabs experience, which raised close to $3 million. Looking at the trend in the first half of 2013, venture capital investment is 15% up on the whole of 2012, and crowdfunding is 26% up. So this shows to me that there is an upward trend generally in investment activity in 3D printing related technologies. And because of the way the market is functioning with respect to investment, it's quite relatively unpredictable, and it can be quite chunky, and one or two deals can create major anomalies if you look at statistical analysis. Key investment activity, a few highlights here. As I have mentioned before, Stratasys purchased Microboards last week, headline number of $400 million, revenue of $13 million. I understand that there's some hurdles, aggressive hurdles for them to reach to hit that full purchase price. I do not know for sure, but I suspect there is. What this tells me is two things, and it tells the market. One is the fact that venture capital firms can make money in this technology. Microboards have received in the region of $10 million published of venture capital money. It may have had more. It certainly had angel money before that. So it shows VCs can make money in this technology. It also shows that there is another purchaser, acquirer in the market other than 3D Systems. Shapeways received a $30 million investment for Andrus and Horowitz in April 2013. Those who are not familiar, Andrus and Horowitz is a very big Sand Hill Road, Silicon Valley VC. That is a major statement to the VC industry, in my view, that this technology is getting to a stage of being ready for absorbing considerable and significant venture capital funding, and because the market is growing and there's anticipation of future listings, IPOs, as well as consolidation, which will inevitably happen in this industry in the mid-term. Shapeways has had about $50 million invested into it to date. Shapeways provides an outsourced service for people wishing to have products manufactured remotely. I had 50 million excluding debt because 3D printing is a capital intensive business, especially if you're looking at commercial machines, which can cost upwards of $50,000, especially if you're looking at high volume, high quality output. 3D Systems has been the major acquirer in the market in the recent past. It has made close to 30 acquisitions in the last 4 years. It's also raised close to $250 million in May 2013. It is listed, it tapped into the capital markets. That will be used, I suspect, for working capital requirement as well as acquisition capital. Crowdfunding has been very useful for entrepreneurs in their garage working on hardware. It's been a great way to get pre-orders, and it's been very, very successful. Many people I've spoken to who have used crowdfunding as a source of capital have had problems in delivering it subsequently, and fundraising has been significantly over expectations. Now that has problems in its own right, as you can imagine, but a lot of the customers on Kickstarter are aware that there can be slight supply problems because of the very nature of the companies that are going there to raise money. I do question whether or not you can really build a big company from just Kickstarter or crowdfunding generally, but it's a great way to show capabilities of building something and shipping something, and that is very, very good. 4 companies have raised over $1 million, and a further 2 have raised over $500,000. So in part competing directly, one would argue, with the angel investment market, and they are not giving any equity away. Just to dwell on a few trends, the maker movement is the hobbyists that were engaged in the RepRap movement, the desktop extrusion technology, which is open sourced, towards more mass adoption. I think there's probably about 100,000 desktop computers in the consumer market, predominantly hobbyists, but the content is booming, costs are coming down, the quality is such that people will accept the quality for the engagement that they get. A story I often say is when I was a teenager, I got a computer in the early 80s, mostly because my parents believed it was good for education and to engage me with a technology. So it's going through a similar process. Back in the 80s, the computers were not particularly useful, but they served a purpose to engage whoever was using them. Direct manufacturing is already here. As I said, 28 million components are manufactured across aerospace, medical, dental, mostly focused through those sectors at high value, low volume. However, in time, it will be higher value, lower value, and higher volume as costs come down. A big issue with the technology in general is education. Allowing people to use it is not easy because the knowledge is not out there. Adoption in the design process is increasing. The majority of products now that you buy that consumer related have been prototyped using this technology In fact, probably 90% plus in the US in particular. A few things that are coming up which people might be interested in if you're in Silicon Valley. I chair SV Forum's 3D printing and scanning SIG. It's a monthly get-together. Next event is on the 1st of July in Mountain View, where we'll be looking at software and gesturing, using gestures on connect and leap, motion, etc. to manipulate objects. And also there's a big show in San Jose in 16th to 18th of September. I will be moderating the investment panel. There is also a show next month in Chicago, Inside 3D Printing Conference there. I think that's the 10th and 11th. So that's my presentation. My contact details are there. I'm done, Roger.
All right, well, thank you very much, Jeffrey. Good overview of 3D printing. Those numbers are really impressive. I'm very familiar with the Microboards acquisition last week, and yeah, very successful exit. So next, Roy Worthington, he's the president of Octave Systems, and Roy, I think you've got a few words to say about the technology and the process and what the business looks like.
Okay, thank you, Roger. Tough act to follow with Jeffrey there. I think he covered it all, so I'll just try and add a few cents worth from my perspective and give you a little bit of background on where we came from with regard to 3D printers and so on. On your screens you can see I'm with Octave Systems Incorporated. We're an almost 30-year-old company, and we started in the very early days of the PC. Our founding company, from which Octave derived, was building a desktop computer some 6 years before the PC was first delivered. That was an exciting time for us. It was an incredible time, in fact. There was a pile of people building what we called breadboard computers. They were being lashed together by the likes of the two Steves, Jobs and Wozniak. They were just up the road from us, and we did get to know them well. A very exciting time. There were lots of kit computers. It was the hobbyist type thing, and so on and so forth. It was the wild, wild west. And in those days, we were saying things like, imagine a computer on your desktop. Wow, what could you do with it? Well, not much. There was no word processing. There was no spreadsheet programs. Even email had not been invented yet. And we had monochrome monitors. Look where things have evolved to in this day and age, and all in the palm of your hand in the form of a smartphone. An incredible 30 years or so. So from that time, let's fast forward 30 years and say where we are with the new revolution of 3D printers. Very similar scenario. It's not a new technology. PCs weren't new when they came, or PCs were new, but computers were not new when they came out. 3D printers, as they are today, have been around for, as Jeffrey was saying, 20 to 30 years or so. But it's the desktop one that is very key here. And while the PC industry 30 years ago moved at the speed of sound, the 3D printing market is moving at warp speed, the speed of light in comparison. And that is phenomenal. It is just totally incredible how fast it's moving. Octave's didn't start 30 years ago in the 3D printer business by any means. As I said, we were in the PC industry for a while. We built clones until the Taiwanese landed here with clones and sort of put most of the manufacturers, American manufacturers, out of that line. And we then got into things like CD and DVD recorders, and for the last 12 or 15 years we've been a major supplier of CD and DVD duplicators, where people were duplicating things for things like church services. In fact, 30% of our business was with churches and so on. We're still in the CD and DVD duplicator business, but that is going away, to say the least. It is a very fast, rapid declining business, but still around. And so about just over 2 years ago, we decided that we were going to get into the 3D printer business. We didn't know much about it, and we said, okay, let's scout around and see what we can come up with. We've joined with a gentleman who's been in the injection molding business for some 20-odd years now, and he sort of inspired us with, okay, we could build a 3D printer. And we got onto this bandwagon of saying, okay, let's go build a 3D printer. And in those days, remember 2 years ago, remember I said warp speed, a 3D printer that was a desktop one came out of the University of Bath in the UK, where they had this thing called the RepRap, which was a machine that would rapidly reproduce itself. It wasn't that rapid, and it didn't reproduce all of it because there were a number of metal parts. I'm going to show you a slide now of the kind of thing a RepRap is. Would you like that on your desk? I don't think so. This was a device that, as I said, the University of Bath came out, and there was a whole grassroots community that grew out of this. It grew phenomenally fast, and these things are all over the world, and they've been developed, both the hardware and the software, in the communal type thing where everybody shared everything. There was no proprietary stuff. It was all, free for all, to say the least. As I said, the wild, wild west of PCs. This is the wild, wild west, as we see it, of 3D printers. It kind of reminds me of I used to fondly call this our flying bedstead, because it reminded me of this. The flying bedstead was a jet engine that you see the pilot sitting on top of it there, and I don't know how much they paid him to fly that thing, but it must have been a lot. So this reminded me of the flying bed, as it was called, which eventually became the Harrier jet, the vertical takeoff and landing jet plane. And I don't think a 3D printer is going to do any vertical and landing and takeoffs, although they are going into space, and that's another interesting thing. So what can you build with a 3D printer? Lots of things. As Jeffrey pointed out, everything from NASA all the way down to the hobbyist. And NASA's using the machines that we handle, which I'm going to get into in a short while, to print parts that are actually being used in space. They are printing micro-satellite boards that are flipped out like a card dealer deals out cards and so on in space. So let's get to take a look at some of the stuff that's printing. From the art side on the left picture there, which it would be very, very difficult to machine that or make that object. To a gentleman that came up to us, well, he actually bought a printer from us 6 months ago now, came up to us at the Maker Faire, which is a vast affair, if I can call it that, in San Mateo, California. They had the 8th one this year, where 150,000 plus people turned up, including this gentleman with this parrot, which was printed on one of the printers that we handle. This parrot is an animated parrot. He's got, unfortunately, we don't have a video capability here with the webinar, but this parrot, the eyes move, the beak moves, the eyebrows, the eyelashes, the eyelids close, and he turns his head, and he animates it through a tube that goes down his left arm, and it is just a phenomenal thing. At the other end of the spectrum, we had a lady that came to us, it was 6 months ago now, and she said, I'd like to learn about 3D printers. And we said, okay, what do you do? She says, I bake cookies. I said, you bake cookies? Well, a 3D printer is not very good for baking cookies. She said, no, I want to make some custom 3D made cookie cutters. Oh, okay, that's a different story then. Do you know what CAD is? She said, no. I'm going to print with, and you're going to have to learn CAD. It's hard to believe that she went away, and 3 months later she came back telling us the story that she learned CAD. She learned how to use SketchUp to produce a 3D printed file, or a file that would be 3D printed, and then made custom cookie cutters, and she was getting 10 to 20 orders a day and working 10 hours a day and couldn't keep up with it. It was just phenomenal. And now she's looking to buy a second printer from us. So that tells you the sort of spectrum. Here's another one of the kind of things that you can print. This was not printed in one piece, either the white one or the color one. It was printed in several and then assembled and so on. But this is obviously the differential of a car, so you can do prototyping and instruction for schools and so on and so forth with them. The printers that we handle, we have two printers, and I'm going to tell you the story of the one on the right, which is the Affinia. And I think I have another slide of it here. There it is. The Affinia printer was born out of a device made in China. And there's a company in China called Delta Micro, which is a spin-off of a company called Teartime. Teartime was formed about 10 years ago. It was formed by 3 PhDs out of the University of Beijing, and these guys were very, very smart. They produced some of the printers that Jeffrey was alluding to with regard to $300,000 machines. And with that technology, they then decided, okay, the desktop market is coming. And they produced a machine that they called the UP. That's UP with an exclamation mark. And they hit the hobbyist market because that was the only market that was there. 2 years ago, actually over 2 years ago, 2.5 years ago, when they started delivering these machines. When we decided to get into the 3D printer business, we said, wow, there's no way that we're going to put a machine like that, flying bedstead, on a person's desk. But this machine, you can, and we do, put it on the desk. But we were not in a position to really handle the service of it. We didn't have the funds to bring 500 of them in, et cetera, et cetera. So we joined up with a company that we had been dealing with for about 12 years in Minneapolis. That company's name is Microboards. They had the necessary ingredients or elements that we needed to make this a success. They had the marketing. They had the service, and the service is very, very key because all of the machines that we've been talking about at the low end have not got any real service backup with 1 or 2 exceptions. The big guys, the ones that make the big guys, have got service. And we feel it's very important that if you're bringing out this technology, these printers are not something like a desktop printer that you would have for a paper printer where you would say, okay, print this file or copy, print this file or copy this sheet of paper or whatever. There's a little bit more, in fact, quite a bit more complexity. And Jeffrey said that education is very key. Getting the user to understand and see what this does is key. But it's coming very, very rapidly. So we've resolved the issue of the service. We've resolved the issue of where this machine is going to go. We don't want to sell to hobbyists. The hobbyists are tinkerers. We want to go down this path. We make it somewhat similar to saying, okay, do you want to build a car and drive it, or do you want to buy a car and drive it? We're catering to the latter in the terms of 3D printers. If you want to buy a 3D printer, there are many, many companies out there that will gladly sell you one. But many times you're going to be on your own, and that's very, very key in what we're addressing here. To have a machine out there that is supported in the field, has a 1-year warranty. And it's very interesting that some of the machines, and I'm not going knock the competition here by name, but I will tell you that check the warranty. There are machines out there, and some of the very biggest ones, that have got as low as 0 or perhaps a 14-day warranty. And the 14-day warranty is such that it's from the date that it's shipped, and if you don't open it, because if you open it, it's yours. And that's from one of the very biggest. This machine that we're talking about with the Affinia has got a 1-year warranty. It's a 1-year factory warranty whereby if anything goes wrong, it's fixed. It's either the part sent to you, or you can send the machine back, and they will fix it and return it to you. So the markets that we're approaching are schools, libraries, machine shops, architects, etc. Your limitations with a 3D printer are indeed your own imagination. We're convinced of that. And we are in several other aspects of this business as well. You say, well, what other aspects are there besides the actual hardware, the software, which is very, very key. There's also the consumables. On the left of this device, you see a reel of filament. We lovingly call it the ink. This is the ink business. And the ink business, this is another version that we've got, where we've got 4-color cartridge, if you want to call it that, where we can print in any one of those 4 colors at a time, and so on. That is a big business for us. And we're also in accessories and tools. We have a toolkit, etc., and various other accessories and so on. It's a very exciting time, and if you're not into 3D printing, we suggest you get into it. I think my time's up on that. I'm going to pass it back to Roger and Yvonne and let them carry on. Thank you very much for your time.
All right, well, thank you, Roy, and thank you, Jeffrey. So that's fascinating, this technology and what it can do. So let's go to a couple of questions. So let me, here's one probably more for me that came in. Somebody is asking about some of the infringement issues, and I mean, gee, can you legally do that? Can you just legally copy somebody's product with one of these printers? And I think the answer is that this is going to be a developing area of the law. You have potential copyright infringement issues, and the rights holders, if they think they're being infringed, are probably going to be approaching some of the websites that host these 3D blueprints. But that's something that we're going to have to be sensitive to and just watch as it develops. Here's one for you guys. One of the things that that jumps out at me as I hear about this technology and this process is that we've really, this is another, as Jeffrey mentioned, this is another cloud service. This is a way of going from a product-based economy to a service-based economy to a cloud service-based economy. And we've gone from a time when somebody might see a product that they like and then they buy the product and the product gets shipped and it gets sold here and somebody taxes the sale of that product, to a system where we simply have some code that goes over a wire and then it gets manufactured here. And I don't know how you tax that is the first issue. And it raises this issue is other than the tax man, who's got the most to lose from this technology and who has the most to gain? I mean, where are the dislocations going to be in the economy in terms of companies that are going to win and companies that are going to lose as a result of this? Do you guys have any perspective on this?
Yeah, I have a view, Jeffrey speaking. I think the companies that will lose will be the ones that do not adopt it as a platform, and not just manufacturing companies. I look at it as there are a lot of similarities with the Internet and computing generally. Internet is an extension of computer, though some people would argue with that, but they all kind of merge together. That it almost became a de facto that you will participate in it. You don't do everything on it, but you do a lot on it. Some businesses do everything on it. I think as this technology does improve, and it's inevitably going to improve, the question is what is going to be the Moore's law equivalent in this technology. You know, there'll be so many people that will be able to come up and create products, and ultimately we all use products. Everyone in the world uses physical things. Companies and entrepreneurs can set up with very, very little cost using services, cloud-based services, or outsourced manufacturing to enter what historically used to be a very capital-intensive business. Also, because with this technology, you can create things that you just cannot make in other ways. It opens up for traditional manufacturers to change their products completely, to improve it significantly. I'm talking downstream when you're looking at really good output from direct digital manufacturing. And there'll be a hybrid process. Not everything will ever be manufactured this way, but a lot of key components will. Because this technology allows you to create exactly what is good for the situation, environment upon which that product works. For example, you know, using the fuel pump in jet engines, you can design a fuel pump such that it's perfect for fluid dynamics and thermodynamics. Therefore, you can reduce the size significantly, and you can increase fuel efficiency massively. And then when you start thinking that you can create anything, you can start using biomimicry. Biomimicry is where you actually mimic nature. Nature's been developed over billions of years through Darwinism, and you know, we can go beyond that because we can iterate quicker than evolution. So I think the ones that are going to fail are those that do not take it, do not get involved, and everyone who manufactures will be using this, and they are now already in prototyping, but down the road is going to be an integral part of manufacturing. That's my view anyway, but you know, maybe I'm a dreamer.
I'd like to add one thing that, and it's a very short one, to answer that question. If you're not into 3D printing, you ought to be, because 30-odd years ago when PCs were up and coming, I was at a school where there was a sign on the wall that said, "Any teacher that is afraid of being replaced by a computer should be." And I think that same sort of message goes here. If you're not into 3D printers, you should be. And that's all I have to say on that.
Okay, thanks. A good comment. Somebody asked if you can point them to some additional resources, articles or books on this technology as well as the legal aspects. Do you guys have any suggestions? You know, they reach out to me. I can send them some reports that are freely available on if you do some digging. There are. Okay, we'll do that. I'd like to let the audience know that all of your questions will be forwarded along to our panelists, and they can respond directly if you'd like to take this offline. Following up. Go ahead. Comment there, Roy or Jeff? Okay. Following up on something Jeffrey had said, you talked about biomimicry, and it raises this question as to what the potential applications are for this technology, and just how far we can extend it. You know, I've heard that 3D printing has been used to manufacture human organs, even.
Let me kind of put a bit of reality into that. A company in San Diego called Organova has or is printing tissue for the biotech drug discovery. So you know they're printing tissue now. Cornell University has printed discs, spinal discs, and implanted them successfully into rats and dogs. There is on the web the concept of printing organs, and I have read somewhere that they've tried it with a rat's liver relatively successfully, but not completely. But yeah, longer term, you know, I've been told directly that we are 10 to 15 years away from printing organs. Now, you don't print just the organ, you print the glucose scaffolding, then you grow the cells onto that scaffolding. But you know, biomimicry, you know, can go beyond our wildest dreams, and it's true and real potential, not just fairy tale.
Okay. So as an investor and as a businessman, I'm sure when you look at a new industry like this, we always wonder where we are in the stage. And pretty much every industry seems to go through this pattern where it starts out, it gets very fragmented, and then it consolidates. And I think we recently just saw the Microboards acquisition a couple weeks ago or a week ago. Are we now in that stage of consolidation here, or is there still quite a bit of new innovation and new applications and uses taking place? Do you have a comment on the state of the industry?
I can give a view on that. I don't think it's at that state of maturity yet for consolidation. We're quite away from that. You know, 3-4 years. There will be acquisitions between now and then, but we've got quite a way to go. You know, I think, you know, looking at that particular acquisition, I could probably discuss it for an hour as to why Stratasys bought it, why they wanted to buy it, etc. The majority of participants in the market are relatively small, and even the service bureaus, where there's loads and loads of service bureaus all over the country, they are very regional, they have very small footprints, and they are very small. I could see there will certainly be consolidation happening in the service area, because that gives an acquirer economies of scale with capital efficiency in particular. The challenge is generally with the market dynamics at the moment is there's not enough risk capital, venture capital, angel capital going into the market to develop some ideas, because the money's going elsewhere. You know, here in Silicon Valley, it's going on software, apps, big data, clouds, mobile, biotech, medical device. So, you know, the talent's not coming in to create the disruption and create businesses with rapidly growing enterprise valuations. Microbot is unique compared to the 150 others that are operating in the same part of the market.
Okay. So backing up a little bit, we have, again, a question. A lot of us first heard about 3D printing when we heard about a gun being produced this way. And I mean, I first found out about it when Roy printed up a bottle opener for me. But going back to the guns, is that really feasible? Is that practical? Can something as complex as a gun be 3D printed?
This is one of my favorites. That when we're at these shows and things like that, people come up to us and in a hushed tone say, "Can we print a gun with that?" And the answer is, you don't have to be pretty clever to be able to design a gun that's not going to explode in your hands, first of all, because plastic is not like hardened steel. And usually at these shows, we point out that there's probably 1,000 machine shops that are within a 10-mile radius of us that could produce a far superior gun, notwithstanding the ability to hide it through airport security and all that kind of stuff. You know, and one of the things I say is, well, if we're going to regulate 3D printers to prevent printing guns, we should regulate Target from selling pressure cookers, which were used in that horrible affair in Boston with the Boston Marathon. So, you know, if somebody wants to make a weapon, they can. And don't blame it on 3D printers. You'd have to be an awfully clever guy to do it with a 3D printer.
And I'd just add, you can buy it cheaper in Walmart.
Yeah,
okay. All right, I want to remind our attendees that this presentation is going to be recorded. You'll find the presentation as well as the materials on royceuniversity.com, the Royce Law YouTube website, as well as in the iTunes App Store as a podcast. And with that, unless our panelists have any other comments they'd like to offer, I think I'm going to go ahead and bring this to a close. Jeffrey and Roy, I'd like to thank you for giving us this presentation. I certainly learned a lot today about this. I guess it's not a new technology, but it's certainly an emerging technology and developing and potentially disruptive technology. And thank you again for being on our panel.
Our pleasure.
Thank you.
Thank you.